So basically, the premise behind the new net pot design is that we've got a standardized planting depth. That's very important in water culture because depending on the grow medium that you use, it can really vary the application based on whether or not you have a wicking grow medium that you've started in, such as rock wool, which when in constant contact with solution can become oversaturated. So having this standardized planting depths gives us some insight into what the water level can be set at. Someone was to, for instance, fill this with something like grow stones. They'd fill it up so that it was flush with the planting deck, set their rock wool cube on the top of that, backfill with the rocks, and then once they put this into their lid, they would set the water level to the second rung, which puts it about a quarter inch below the rock wool. What that does is it ensures we don't have that constant wicking going on and potentially oversaturation, botrytis, and problems that'll come from that. If someone is doing a bare root cutting, which is typically what we recommend, they would do the same process of pre-planting with grow stones or hydroton or something like that. They set the bare root cutting on the planting deck, fill in with grow rocks. Now for that grower, we would recommend that they raise their water level up to basically right at the base of the solid part. And that would submerge those roots and you've got your plant growing in water culture. So there really isn't the likelihood of having some of the issues that can occur with wicking grow mediums. That's the primary reason. Now we also get some benefits from having the heart or core of the root mass basically have some atmospheric oxygen that can make its way in there. So again, that's fighting stem rot, botrytis, things like that as well. And with that said, we also are looking to promote lateral root growth. So instead of getting a few spindly roots that are coming out, we're looking for more of like an inverted afro, if you will. And once you get that, you have a big, strong root mass that can grow into the solution. Aside from that, the function of the system is essentially just to recirculate the solution, keeping your constant EC and pHs and water temperature as well. Water temperature is really important in water culture. We're looking for probably the mid-60s. Preferred water temperatures can range anywhere from high 50s to mid-70s. Once you get above the mid-70s, you start running the risk of having root issues. Benefit from the usages of foliar sprays. So putting things in foliar sprays and administering to plants, a lot of the active compounds and things that are beneficial in those organic based solutions are beneficial foliar as well. If they are going to put something in solution, so literally in solution in the system, we usually say break it down to a 16th of the strength or an eighth, what we would consider a homeopathic dose. If whatever compound is in that organic that is beneficial will be more easily uptaken and you don't get the side effects such as residual biofilms and things that can happen. So that's the main problem. Other things that can be done is that you can just top what we would consider a root drench. Those types of things like inoculants right to the root zone with maybe zero runoff so that you're not jeopardizing the chemistry of the water to give your plant some. So you're basically not having the trade-off of a benefit, but you're getting a drawback as well. So those are probably the best pieces of advice we'd say, because we definitely don't want to see people have to discriminate against organics. There's obviously great things to be done, but with water culture, you're kind of setting yourself up for some potential issues that you may have to deal with. So we find the best way to deal with an issue is to avoid it. Very soluble mineral salt-based solutions. Some of the products on the market that we've seen do real well in the system is Ionic, Dutch Master Gold, Canna, the House and Garden line, the Aqua Flakes. Those all have very nicely chelated, available mineral matrix of nutrients, and they tend to stay pretty stable. We have a new nutrient that we released specifically designed for water culture, referred to as cultured solutions, and it meets the mark on all those things. What we've done is we have all the chelates and things in place. Given that water culture, your plants very much are what you eat. You have no buffering going on like you do in a grow medium. So a grow medium can hold on to certain impurities and maybe not give them up. Water culture, what is in the solution is absorbed by the plant ideally. So we're pretty, I don't know if you can say idealistic about what we don't put in the solution. So it's very pure, and one of the important Yeah, one of the important elements is the proper mineral ratios allow us to not have excesses of any one thing. So it's what we would consider a very low salt index. So a peak, maybe during flowering, peaks TDS or EC for a fully maturing mid-bloom heavy feeding, 700, 800 parts per million, maybe a 1.4 EC. You know, that's pretty reasonable, and that would be peaking.
Okay. So you do recommend a lower ppm, a lower
Absolutely.
Using a system like
Yeah, we would say what we found is in water culture, especially recirculating, that it's about half the recommended hydroponic strength.
Now with DWC, with water culture systems, because you have so much root mass exposed, do you recommend people using enzymes more often than a soil system or a regular, ebb and flow type of system?
We've actually found the opposite, that obviously there's differences in enzymatic products on the market, but based on the fact that you don't have a lot of dead and decaying root mass or biomass at all in the system, you really don't have a necessity for those enzymes. So what we find is keeping more of what's quite often considered a sterile approach, or just what we would say is a highly soluble approach, very clean. So sometimes what you get is residual effects or side effects from those enzymes, such as small films building up, could be on the root mass, that can hinder the uptake of nutrients, air stones, things like that. And that's the problem. Maybe it's not so much whether or not the enzyme could be beneficial, and it could even be the carriers or the inert components of those products that cause problems. As a maintenance, gosh, there's a few products in particular. Zone is one of them. What we have is UC Roots, and what UC Roots is it's a proprietary acid. So what it's doing is it's descaling. Now, what's nice is, though it's technically an acid, it's very pH neutral. So when you put it in solution, it's not changing the pH of your solution, which is important. You don't want to have to fool with that. Now, what's important is it's going in and it's constantly descaling and solubilizing. So if there are things such as calcium and magnesium, which are we all know are so important for plant health, it's keeping those things available in a form that's being uptaken by the plant, as opposed to depositing, precipitating out of solution, and making for a potential pathogenic habitat, essentially. So that's what's really important with that particular product. Now, you can use H2O2, but we like to see it used more as a tool. So if you consider your IPM approach to water culture, you want to have tools in your toolkit, but you don't necessarily want to use them on a regular basis, so that they're very effective when you do. Now, the nature of H2O2 is it's slightly caustic, which is why it works well when you have a root problem. You exfoliate the damaged root material and it can heal. So used constantly, you could argue that it could be a bit of a hindrance to healthy root growth. Now, with that said, when used properly, it really helps. So people do use biologicals in the system too, but again, what you're looking to do is you're looking to introduce something that basically, instead of populating, sets a presence up, so that in the case you get conditions that promote pathogenic problems, maybe even anaerobic pathogens, you have something in place that can then start to compete with them. The whole premise behind using compost teas is that you are introducing a neighborhood of something so that you're not subject to whatever might want to show up. And diseases are notoriously opportunistic. That's a good question. There's a few observations we made over the years. One is your water will normalize to about the ambient temperature of your room. So let's say someone's using CO2, they've got an 82-degree room. So theoretically, they've got 82-degree water. Our target's 65. Well, the big difference there. So aside from using chemical means to suppress disease, we definitely would say chill your water. If you're doing recirculatory water culture and you can, chill your water, absolutely. So obviously chillers are the best means of getting that done. As far as sizing them, just looking at the total volume of the solution and taking and having, in this case, you want to drop the solution 20 degrees for whatever the volume of your solution is. Double check with the manufacturer of the chiller. We would recommend contacting Hydro Innovations. they're the experts in the industry on cooling in general, and they are very familiar with water culture systems, hydroponics in general. They can give end users and store owners alike very concise sizings for units they're going to need. Now, long-winded answer there, but what we've also found through working with Hydro Innovations is that your water actually works to pull the heat out of your room. So a grower has an air conditioner that is charged with keeping the ambient conditions at X. What happens is, in the event that your water does absorb any heat, your chiller now is working to cool your room, because your water is now the thermal mass that pulls that out. So as long as you're looking at it from that perspective, even if your chiller is working harder to cool your room, it's technically taking a load off of your air conditioner. So it's just a trade-off of how it's being done, more so than it is a detriment. You just need to plan accordingly. And definitely using things such as we have, you can see over here.
So if you're concerned over direct heat on the top of the buckets due to the grow lights, you can always use a reflective bubble material, such as this. And if you want, you could actually maybe blanket it over the system.
Absolutely, you know.
And that will help with direct contact light heating the unit.
So let's just quickly go over pH and water temperature. As I mentioned, water temperature, mid-60s, is a great place to be. It sustains higher levels of dissolved oxygen in solution. It enables you to use slightly lower TDS, because at that temperature the solubility is still good, so that the permeability into the root zone is high. And most definitely it also inhibits the growth of disease organisms. So those are very important things. Now, as far as pH, we typically say anywhere between 5.5 and 6.5 is a range where if you're in there, you really don't want to change it. So if you have a solution that's notoriously drifting, as long as it's along the lines of, say, 1/10 of a point a day, you really don't need to be concerned. If it's moving more than that, you might need to take a second look at the combination of things you're combining together, because it is what's dictating the water chemistry. And so it may just be one input that you're putting in that's making that drift happen. Now, what's counterproductive is if you have to get in there and change the pH. So you're adding in another chemical which can basically destabilize the nutrient and make it less or not available for plant uptake. So that kind of stalls the whole process. So if you're in between the 5.5 and 6.5 range, it doesn't necessitate changes. If you're using a solution that nails you in and can keep you there, that's perfectly fine. We'd probably say shoot for about 5.8, maybe during veg 6.2, but anywhere in that range right there, and you're looking good. You know, the only other thing I touch on is one of the common things that we recommend for use with the system is a top-off reservoir. And what a top-off reservoir for us means is a reservoir that is interconnected to our float valve in the epicenter to keep and maintain the solution volume. And as opposed to dripping in water and diluting down the solution, what we have is a pre-mixed solution.
Oh, so instead of doing a freshwater top-off with the float valve directly from your faucet or your hose, you guys recommend a mixed solution.
Right.
Reservoir.
Because what works best with the UC is that we're looking to have the ratio of water and minerals being uptaken by the plant equally. In the event that you had water being uptaken more than minerals, your EC is going to climb, necessitating fresh water to dilute it down. Well, if that's the case, then we're looking at the problem being that your EC is a little too high. So if you bring it back down to the point where the volume of the solution is diminishing and you were to check it with a meter, you actually would have your parts per million either stay the same or dip down slightly, so the minerals are being consumed at a little higher rate than the water. And what that ensures you is your plants are hydrated at all times. Keeps maximize your plant metabolism. And then what you would do is you'd shoot in your top-off reservoir to have about the same that you have in the system, assuming that the plants are consuming it as a whole. You've got it right. So you're not doing something to make up for what's gone wrong. You're giving them more of the right thing. And then what you can do is in your top-off reservoir, I'm going to be the imaginary top-off reservoir here, going into the system, you can set that for your next week, because your plants should be literally consuming the solution. And if they are, then it's evacuating away. So that's where someone could theoretically do a zero change out. But in a zero change out, it's a bit of a farce because your plants are changing it out for you. So as opposed to taking a high volume of solution and dumping it, your plants are using it, evapotranspiring away the water and using the minerals in the photosynthetic conversion. So they've consumed and used everything, so you're going to continue giving them that. What we found is in a situation where plants are thriving, you might have a plant use 3 gallons of solution a day in heavy bloom. Well, you look at an 8-site system, you're going through 25 gallons of solution. They could change the solution out in 2 days. A lot of growers will have 7-day periods. Well, they literally are changing it out theoretically more often than someone who does a zero change out, but they're changing it less because the plants aren't using it quite as efficiently. So it's a bit of a perspective thing, and we found which works better for us is giving plants dosages they can consume as a whole. You know, we touched on the net pod earlier. That's fairly new, and that has a couple cool features that we went over. We've got the nutrient solution, which has been really well received. We've had it out on the market for about a year with our testers, and we're just starting to make it available. It's just getting registered in California and a few of the other states. We'll slowly tackle state per state. And you know, like I'd mentioned earlier, part of the virtue of this particular nutrient system is that it's very stable, it's very clean, it's also very simple. We've got an AB veg, an AB bloom, and we've got a bloom booster. So, you know, when it comes right down to it, what we found is with that simple nutrient program, you can attain fantastic results. So, though there are different ways to approach it, this is the one that we found works best with water culture. Here's the thing that makes cultured solutions different. It was essentially blended specifically for water culture. And so what we found is, though something is hydroponically appropriate, water culture is its own beast. And so it was a benefit for us to have something that worked well in water. And that was where I touched on chelation earlier, being very important in making sure everything was solely available for the plant. So outside of the culture solutions, we do have a drain to waste system that's going to be appropriate for use with organics and soil that we'll be releasing within the next month. And we're real excited about it.
Thank you, Daniel. We really appreciate your time.